Hello, my name is Javon Anderson.
Hello, I'm Javarian Hurd.
And I am Ryan Hooks, and we're going to talk about our phase diagrams. Let me get a marker right here. So I'm going to start by drawing off the PT diagram. So I'm going to draw the chart right here. First, we have this line that goes, so on this line right here, this line is your pressure, and this line right here is the temperature. So you draw a line that goes about, I'm sorry,
Goes like through the
block the
middle.
camera a little bit, bro.
Goes through the middle.
So it goes through
Like
the middle,
that.
and then you have another line that goes right here.
Correct.
So in this diagram, you have three different phases. At the bottom right here, you have your gas phase.
This is your solid phase.
This is your solid phase right here. And right here is your what?
Liquid.
Liquid phase.
You ready to talk
Okay.
about
And in these, it has different points, such as in the center right here,
it? This is your triple point.
this is your triple point.
Triple point.
And you have another point, which is about right here,
Critical.
and this is your critical point. And the substance can change between solid, liquid, or gas when it crosses over any one of these lines. And if it goes from the gas phase over to the liquid phase, this is called vaporization.
Vaporization. If it goes from liquid to gas, that is called
Condensation.
condensation.
Yep, that's right. So if it goes from liquid to gas,
Condensation. And from gas to solid is sublimation.
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 from gas to solid or from solid to gas?
From gas to solid is sublimation.
Got you.
And this is a PT diagram.
And basically, I'm gonna give another better description for this. So when you add, like, okay, if the pressure is constant, like right here, and you increase the temperature, it's gonna start it off as a solid, then it's gonna go straight to a gas through sublimation. But if it's at a certain pressure, it's gonna go from a solid to a liquid. It's gonna keep going, and then it's gonna go to a gas. So it really depends on the pressure and how it is. And this triple point right here is basically a point where it's all three substances at one time. It's a solid, liquid, and gas at that specific pressure and temperature. And that's it. That's my PT diagram.
Okay, I'm gonna start with the PV diagram. So it's gonna be the pressure and the volume diagram. So I'm gonna start with drawing. Hold on.
That's
So you got your pressure right here. This is the volume. So I'm gonna draw the curve. This is the curve. So at the top of the curve is the critical point. Right here.
What is this region called?
That is the liquid.
So this is the liquid region. And this is, if I'm correct, this is the two-phase region, right?
Correct.
Okay.
This is the two-phase region. Then this is the vapor region right here.
Okay, so we have in total 3 regions.
And so we also have the critical point, which I said, this is the liquid region, this is the vapor region, and the two-phase region. So this is when they both are together. So in this, we also have 2 points right here. You got 2 different type of lines. One is a bubble and one is the dew.
This is the bubble point.
And what happens at the bubble point?
So I guess at the bubble point, the gas is, I guess, gets heated up extremely.
And it starts to, actually, like it says, it starts to bubble.
Yeah,
Like boiling water. It's bubbling.
correct.
Okay, so what's the other one is the dew point line.
Dew point.
Mm-hmm.
Okay. So
Explain the dew point.
the dew point is when the dew point is when it comes from the vapor to trying to become to the liquid region.
Mm-hmm.
So it's
Like an example of that is when you like, let's say you're outside in the mornings and like you see all that dew on your cars and on your grass, stuff like that. That's the water vapor in the air actually switching over towards the liquid phase. So that's kind of an example of something at the dew point.
yeah, correct.
It has to be a certain temperature, a certain atmospheric pressure. It has to be in the right conditions just to get to that dew point.
Correct.
So this is a PV diagram, and there are three common types of PV diagrams. You have isothermal, you have isobaric, and isometric. And isobaric is when the pressure stays constant throughout the whole diagram. For isothermal, the temperature stays constant throughout the whole diagram. And for isobaric, the volume stays constant throughout the whole diagram. These are three of the most commonly used PV diagrams.
And with that, this is our conclusion of our video. I hope you learned something that we know in class. And right here again, we have our PT diagram, description of everything, and right here we have a PV diagram.
PV diagram.
Thank you.
Thank you.